Well, good day, everybody. This is Tony Paquin. Want to welcome you to another podcast of the Supply Side podcast. Excited to have you join us today, and particularly excited to have as our guest my very good friend, business partner, chief technology officer at iRemedy, but also CEO of Grokkit Data, Jim Harding. Jim, say hello to everybody.
Hello.
So we're going to take a little bit of time today to talk about the big buzzword that everybody seems to be chattering about, artificial intelligence, but particularly some technology that Jim and I began discussing about now maybe 4 or 5 years ago, and then Jim put together a group of really great developers and scientists and began to develop some ideas in this area of AI, but we're going to want to discuss that a little further about what does that really mean. But some really super exciting things, and part of that resulted in a series of patents that have been filed, and several have now been issued. So we'll talk a little bit about those patents as well. So, Jim, just to kind of get things started, and I don't want to rehash our backgrounds too much, but it's important to get kind of establish some history so that when people listen to or watch the podcast, they understand that both you and I, and particularly you, have done a lot of work in this area over the years. Kind of interesting. Jim and I have known each other for, I don't know, 5 plus 6, 7 years, but we're similar age and we both grew up in the technology world, albeit in different areas. And ironically, about 20 years ago, we both sold some software companies to the same company. We actually came close to working together probably 20 years ago. Jim, you sold, I think that was, you had like a application that did insurance premium financing or
Yeah.
something like that. You sold to
hmm
Vertifor. Yeah.
Yep.
And then I had an agency management software product that I sold to the same group. And of course, Vertifor has gone on to become a $1 billion company. So quite a bit of success there.
Yeah, they're a Seattle
Jim, your
company that was a
background.
software company 20 years before Microsoft.
Yeah, exactly. Wow, that's interesting. So that's actually, for you, Jim, was kind of interesting start in the software industry. I sort of stumbled into it because my brother Gary sold me an IBM computer that didn't have software, and you had to go figure out how to, write code. But Jim, you kind of came out of college in Washington and were doing some kind of homegrown work with a group of guys building computers, I think, and that forced you into a world where you had to create an operating system. Isn't that how it all started?
Yeah, I was a research assistant at University of Washington, and there's a small computer hobbyist company in my hometown, Tukwila, south of Seattle. And I had seen some of the boards they had built over the years, and it's in hobbyist magazines. And I went down to check what's going on, and actually going down to buy myself a Volvo near there. And I never got the Volvo. I ended up going to work for them, and we were in the midst of a revolution that was about to happen. And at the time, I had been working on a control data mainframe at the University of Washington. Tim and Pat were both electrical engineers. Tim Patterson is the author of DOS, and so we were working for him, just wire wrapping our own boards. And people don't probably know what wire wrapping is anymore, but you'd buy chips, you'd buy these circuit boards, and then you would solder these chips to these boards and put them in an S100 computer. Buy an off-the-shelf S100 box. And we'd build our memory cards with Intel 8086. We'd build our disk controller cards. We'd build our various other cards that would go into this thing. We'd call it a computer, and it's just a hobbyist thing. Well, lo and behold, that became QDOS, and it became the story goes it became Microsoft MS-DOS and PC-DOS. But in those days, we built everything. So today, if you buy a computer, I mean, it's all outsourced, every single component. Whereas in the old days, we would buy everything and build our boards, plug it into a chassis, and we
Yeah.
had zero
Yeah.
applications. Like all we
Yeah.
had was assembly language.
So, but yeah. So, the deal is though, just kind of set that, background a little bit. I mean, you worked, in the very early days of Microsoft and helped create the DOS program that they launched with. I think you did some database work there as well, kind of
Yeah.
database advisor. I know you appear on at least one patent that I saw. I think that was with Paul Allen or somebody
Hmm.
of that nature. Years later, you developed a couple of companies that you end up selling to Bezos at Amazon. And I think one was like a photo sharing deal, or what was
Yeah.
those
Well,
two
the
companies?
first company was Cartia, and that was a spin out of Battelle Laboratories in Eastern Washington, Battelle Memorial Laboratories, and we built a software system that was surprisingly similar to what large language models are today. That became uh, after Amazon bought us, that became a lot of their early AI work, the recommendation engine. If you recall with Amazon, and if you bought this product, somebody else probably bought something similar. That's called collaborative filtering. But we were also doing um, this, vector-based machine learning back in the late '90s, and there's really not much difference between what we did in the '90s. We weren't even calling it machine learning back then, and then what Amazon adopted, and then what we have today. So these things called large language models, I would say that we were doing the same thing, but it was like, let's call it nano language models, very tiny, because
Yeah.
think about Moore's law across 25 years there. What we had back then were pretty rudimentary computers that took days to build a model, and the number of topics that we have in that were pretty small. But nonetheless, like the NSA purportedly had been using this to find terrorists by sniffing email on the internet, and they look for patterns like a certain city in another city in the Middle East, and they pick up. So our topic vector mapping would pick up signals like uh, fertilizer and tons of fertilizer in different cities. That correlation would say this is highly correlated to terrorist activity. And so that's the early days of machine learning. We then took it to the internet, and we were using it for search. Probably the first company to do machine learning on the internet. And it's funny when you think about today, it's just orders of magnitude larger. And these
Yeah, that's why I
yeah,
always think of when, people talk about like ChatGPT, for example, and the LLM thing, which is very cool and phenomenal. And we're doing some work at iRemedy with it. And we've talked, Jim, you and I, about how we might interact with that LLM thing. But it just seems like really what it is. It's a lot of what you have done in the past, but just at this really incredibly larger scale, right? I mean, isn't it
yeah,
really in a lot of ways? Isn't that what it comes down to? It's just a
yeah. It
whole
does
lot
come
more
down. So
data, and of course the speed that goes with it. You know,
yeah, well, it's interesting that the history of AI, goes back to 1950s, late 50s, 60s, and AI was a thing, every decade, and there's a lot of promise that didn't get fulfilled. And the term of art that we would use is this thing called the AI winter. And there was one in the '80s, the Japanese and the fifth generation of AI. That never happened, but a lot of books were written about it, and a lot of us, kind of jumped on the bandwagon. Think programming languages like Prolog and so forth were used. No one really uses that anymore. It wasn't really a good way to do things. So that was an AI winter. People stopped funding it, and then in the '90s, another AI winter came, and we'd been building, well, we in the industry had been building, natural language processors, speech recognition and so forth,
right?
and they were sort of working.
Yeah,
I was working for Paul Allen, then he had a company doing AI, and they would take. This is not too long ago. They would take, and this is kind of old, what's called good old fashioned AI. They would take encyclopedias and they encode that with logic languages. That would cost, several $100s per page to encode that with an encoder. Well, that was the way that speech recognition, a lot of the AI was going on, but it was very expensive, tedious, time consuming. And so these AI winners had come and gone because there's all this promise and no one could really use them very well commercially. Well, then after the AI winners had kind of gone and things started thawing toward the late 2008, 9, 10, 11, you had all this data coming because of Moore's Law. So you had a massive amount of data you could collect
Right.
for the first time. Your processors are running faster. We decided to stop using CPUs and start using GPUs, graphics processing units. And they're good at doing a lot of
Yeah.
floating point operations. Well, you use floating point operations because you have these vectors of floating point numbers that represent topics. Well, those got denser, data got cheaper. And around 2011 or 12, then you had the Chinese, you had Facebook, you had Google, you had Microsoft, Amazon, all coming out with these incredible breakthroughs in terms of image recognition. So you run that fast forward, you got Tesla
Right.
doing automated driving because it can detect images.
Yeah, I remember
So yeah,
that whole there was that company, it was called like Dragonfly or something, but they became a medical transcription company
no,
during that period.
it's nuance, and the company they had Dragon.
Yeah,
So you would see doctors with
yeah,
this thing hanging around their neck that would pick up voice recognition. Well, interestingly,
yeah.
that company got bought by Microsoft for $17.5 billion just a year or two ago. Well, interestingly, those guys had
Mhm.
initially done the symbolic or good old fashioned AI, logic based systems. The thing is, the linguistics behind natural language like English is pretty complicated and it's nuanced, if you will. And what happened is there's a transition of time where everyone was trying to deal with logic languages and coding linguistics. And then machine learning became
Yeah,
so prevalent, basically dealing with data and statistics. You see enough of these words, enough of these sentences, you can sort of predict it. Um, they got really good and moved to a machine learning version of that. So I don't think anyone's really doing linguistic based, old fashioned AI on speech recognition. Well, then what really happened, the magic behind large language models is that you take a chat GPT interface on top of a large language model with trillions of parameters in it. That's
yeah,
it's somewhere between two, three, $400 million went into over a few years
yeah.
of
That's
building that data. And what happened was now you had all this language that you can sort of predict next word, next sentence. And now all of a
yeah,
sudden, natural language understanding, which is machine to understand what you're saying, and natural language generation popped out. And so now it's a whole new game. And that's why we're not only out of
yeah.
the AI wonders, we're sort of into this AI summer, if you will,
Right. I thought
where,
it's really
yeah,
interesting to see where it will go, right? And it has to do with, as you point out, is that massive scale. We were
yeah.
talking about I was talking to somebody on the banking side about investments in LLM, for example. Well, you want to jump into that business, it's a multi-$100 million, early stage gamble. That's because the scale is just so big in that world. Just to
Well,
kind of
yeah.
clarify some of that, some of your terms a little bit, the AI winner ideas where you're talking about sort of seasonality of, as the industry was developing, it went through periods where, it cooled off, so to speak.
Yeah,
Things
the
didn't
cooling
work
is
out. And
basically investment. So no
yeah,
more investment going on these winters. And then what's happening now?
yeah,
It's this AI summer because there's a company uh, recently had I don't know $13 million put into it by just a number of venture capital companies, like all putting $5 million
Yeah, it's
in, right?
amazing. Yeah.
And they don't even have
Yeah.
a product yet. So you've got this sort of frothiness going
It's
on here with
incredible.
this
Yeah.
these valuations. The thing is, my point is that what it did was it created this natural language understanding and generation. So when you do it in chat GPT, you
Yeah.
type something, that's natural language understanding. And then when they generate something for you, you know, perfectly spelled out, well structured, that's natural language generation. So we couldn't do that very well in those previous AI attempts. But the
Yeah.
problem
Yeah.
is, and the thing where what we're looking at, like that as a backdrop, um, you see some of these NVIDIA, Jensen
Right.
Huang, the
Yeah. Of
CEO,
course.
he's having a good run. He's up 300% this year in his stock. People can't get enough of his chips. But interestingly, he
Well,
says,
it's
like, we're sort of,
amazing. I was
yeah,
reading about just, some of these setups. They're going to those chips and they're setting up one computer with like 1,000 chips or something.
yeah,
Just the scale of that is incredible. It's an interesting thing. I want to get to the Grokkit part of the conversation, but one of the others, so what you get in the LLM essentially is now you get that two-way dialogue. So okay,
yeah,
that's very interesting. The other kind of mega trend, if you will, over these last 20 years, I always hate to sort of date myself because I realize how old I get, but if I go back like you did to really the beginning of the internet. You think that'd be 100 years ago. It wasn't really that long ago. But this idea, it was like Tom Watson, the CEO at IBM, said in the 50s or something, the entire world market for computers is like one or three or some ridiculously small number, right? But in many of the conversations, Jim, that you and I've had over the years is how the proliferation of computers has almost or has in fact surpassed the proliferation of humans, right? We actually now have so much activity on the so-called coming out of the so-called information age. It's like we got too much information, most of which, by the way, is junk. But we have this huge, massive web-based world out there that has become sort of impossible to manage, right? It was
yeah.
it was when you and I were kind of coming up, and you had Apple and those guys, and they had the vision of a computer on every desktop. That happened when you were at Microsoft, or your the beginning days of some of the work you did with Microsoft. But it was just almost unthinkable that everybody would have a computer. Well, I don't even know the numbers you probably do, but
Well, yeah,
what's the average number of computers per
yeah.
person today,
Well,
right?
yeah. The What's interesting. So going back to IBM, so there's a there's this. This is a fun point in history of the first online system. So that there's a developer on a plane, an American Airlines plane, sitting next to a guy, talking about computing. Well, the guy he was sitting next to was the CEO of American Airlines. And on that flight, the American Airlines guy is saying, "Hey, look, it takes 90 minutes to do a reservation. Can we do something better about this?" So he said, "Let me go back and talk to my friends at IBM here." And that conversation turned into what's called the Sabre system. And so the Sabre system effectively was two 7090 IBM mainframes. So of the three that Watson thought we'd need, there's two of them right there. so there's two 7090 mainframes, and they hooked up 1,000 terminals, these online terminals. These are dumb terminals, screens. They had some chips in them,
Yeah,
but
yeah,
they had their own protocol back then. It wasn't HTTP, wasn't TCP/IP, wasn't anything like that. But they had their own protocol, and they wired these 1,000 computers up around the country, and you had 10 people per
yeah.
terminal, so you had like
This
10,000
is not.
online
This is
users.
not it. Yeah, for all the young people in the world, this is not. They were connected up by the internet. Okay, this was
No,
literally these dumb terminals, more or less via a cable or, a series of networks over phone
mm-hmm.
lines or whatever, but connected into that
Yeah,
mainframe. It was one
it was
computer, a
it was
thousand,
yeah,
keyboards, if you will.
yep, it was absolutely amazing. Now I wasn't there for that, but the story is amazing because now
Yeah,
they were doing them in 3 to 9 seconds versus 90 minutes. So that changed the game. In fact, Travelocity is the result of Sabre. So it went through many, many iterations. But the thing was, back in 1960, when they launched that, there were 1 million people per CPU, if you will, on Earth. Today, there's about 25 CPUs per person. So that's a
Right. So there you go. So that's the difference, right? So let's go back to that for a moment. So there was about
yeah
1 million people for every one, what we would call
CPU.
computer,
Yeah.
CPU, right? And
Mm-hmm.
today, going back to what you just said, did you say it was like 25 to,
25 CPUs. Yeah. The
per
the
person?
interesting yeah the
Yeah.
interesting thing is now we can't really count all these data centers with all these GPUs from NVIDIA as CPUs per se. So they're not CPUs, they're GPUs. They're the special processors for crunching floating point numbers. But where things are headed is, if you look at the trajectory, um, there's so Moore's law is pretty much over. We can't get below 3 or 2 nanometers. So physically, like a hydrogen atom, it's like a half a nanometer across. So you're not going to get. We can't go beyond these physical limits. So Moore's law is it's pretty much ended. It's plateaued, but that doesn't really matter um, the way I'm looking at it, because
Yeah,
what
let me
happened?
clarify that
Yeah,
for people a little bit though. So Moore's law was always on this idea that as computers got smaller, they got cheaper, the power would go up. So they got cheaper and faster,
yeah,
come at a compounding rate, right? And
yep,
what you're driving at now is they've just gotten so small, like they're down to the microscopic
yeah.
microscopic size.
You just
Right.
can't etch circuitry
Yeah.
below that. Well, the funny thing is that people talk about Moore's law. Like he had Gordon Moore, he had a second law. So when you think about Moore's law, it's always the first law, but no one talks about the first law. The second law is a corollary to the first law. The first law is like, the density, the cost will decrease by half every 18 months, 2 years, right? The
Yeah.
Moore's second law is that the cost of fabricating the next generation of chips will double every 4 years. Okay. So it doesn't take a wizard to figure out, okay, if if we plateaued on Moore's law, first law, things aren't getting denser, the cost every 4 years is doubling. We're at this inflection point where we no longer can count on Moore's law to help us. And what's interesting is that so Barclays did a study on productivity. So from 1760 to today, worker productivity, unit per the amount of work per unit time has gone up 30 times in the last 250 or so years. But um,
Hmm.
if you look at that, the greatest slope of productivity has been the last 30 years. And that's because of the internet and because of the effects of Moore's law once you get into the density we have now. So even though we've run out of physical room and it's going to cost us too much to get any further, um, it doesn't really matter so much because the cost of replicating chips is going to go down. It's
Yeah.
not the
Yeah.
cost of manufacturing is going up. That's not the issue. The cost of replicating is going down. So what's going to happen is I'm going to hit you with a ridiculous number, but if we have 25 CPUs per person on the planet right now, and
And they're more
productivity keeps
powerful and they're
yeah
more powerful CPUs than they've ever been before.
yeah,
So when you really
but we're
think of computing power, you're like,
yeah
you know, right?
yeah.
Yeah.
So what's going to happen is, and see, we're not really good at looking at huge trends. So in the 70s, we had thousands of people and thousands of computers. In the 80s, because of
Hmm.
the internet, TCP/IP, email, and the PC revolution, we end up with millions of people with millions of computers. In the 90s up to now, we end up with billions of people and billions of computers because of HTTP, the access on the internet. The next generation is
Yeah.
trillions of workers. And no one's talking about that. And so the number I'm going to
Yeah.
hit you with is just kind of a staggering one. But you and I go back to the 90s when we first saw the internet, and we didn't expect it to, we had no idea.
Right.
No one had any idea.
Yeah.
When in the 80s, heck, I'm working on the first PC, if you will. We had no idea like what that would do. So we couldn't see things. Now we can.
Yeah.
And so the staggering number I'm going to hit you with is that we're moving toward the number of trees on the planet is the number of CPUs that we'll be using in a few decades. Now, the number of trees is about
Jeez. That's
3.5 trillion trees on the planet, right?
wow.
So you think about that, we'll never get that. Well, in 1983,
Yeah.
January 1st, when TCP/IP came out and was standardized for internet, no one thought,
Yeah.
millions of people and millions of computers. In 1991, when HTTP came out,
Yeah.
no one thought billions and billions. What I'm talking about now and what we're doing with Grokkit is we're
Yeah. Exactly.
preparing
Let me
ourselves for
introduce that.
that time. Yeah.
Yeah, let me introduce that a little bit because we've had some great conversations on that subject, and all of that is to say, I kind of remember in the what it'd be in the 2000s or 2010, that time frame. We were talking about the information age, and we thought it was this glorious thing where we would have all this information, right? To your point, what we've built now is a world that has more information than we're able to manage, right? And we talk and even in the kind of political, society, social world, we even talk about it, right? The Twitters of Facebook, social media, just all the content of the world. But beyond that, just the functional B2B activity, running companies, right? Everything's gone to the web. Every software application's on the web. And what you ended up with now is this overwhelming amount of computing activity, just computing activity. It's sort of like if you had trillions of trees. Well, yeah, but the computers are causing work for us to do, right? They're overwhelming us with activity, some of which or much of which is meaningless or worthless. But as we live our lives as humans on this planet, there's like so much computer-based activity to interact with. It's impossible to keep up with it. You can't exponentially grow this the computing side of this equation and somehow expect the average person to come into work and use that technology effectively or not be overwhelmed by it. And that's sort of where you started to kind of address the Grokkit, to address that problem with Grokkit. It actually started out with a conversation I had with you about 5 years ago because I came to you talking about my frustration with catalog management in the medical supply world. And of course, you had, one of the best catalog management experiences in the world. That was Amazon. And you were explaining to me like, yeah, it's a big data problem, but the world is in a different place. And now there's technologies that can be developed to help manage that big data, that high complex big data problem. That's really what started you down the road of the Grokkit, inventions. Grokkit, for people who are listening, is Grokit. By the way, we should take a moment to explain where the word comes from. But if you want, Jim, just kind of talk a little bit about that need, that overwhelming kind of computing world, and then developing the tool sets to help people manage or take advantage or leverage that computing
Yeah.
capability.
So all we have to do is just look at I don't have it in front of me, but visualize a graph that shows a 30x improvement over 250 years. And you look at this arc, right? And it's pretty
Yeah.
steady. Well, that arc was long before we had computers, right? So we only had computers for 60 years, 63 years since the Sabre
Mm-hmm.
system. And so that arc, the steepest part, from the 90s up, was because of this interconnectivity and because Moore's law had taken off so much. So the problem we run into is, so say we go toward the number of trees on the planet with CPUs, like we don't have enough people to manage that, right? So we have
Mm-hmm.
this nice correlation of thousands of people and thousands of computers, millions and millions, billions and billions, nice and convenient. Everybody on the that needs to use the internet can today. It's only growing about 5% adoption rate because we've saturated it, right? By 2030, we'll have 6 billion. Today, we have 5.1 or 2 billion. But that's not significant. What's significant is the proliferation of these CPUs, if you will. And so as we get more and more CPUs and we have more and more demands upon us to do more and more stuff to keep up competitively in whatever business we're in, we have to be more information aware, and we have to work at a faster rate, more intelligently. So the large language model thing is this interesting blip in the curve, in that the way to look at it is rising tides lift all boats. So yesterday we didn't have it, today we do, and everybody in the world has it, right? So now we have access to effectively like a workforce of 2 million people at your beck and call when you type something into ChatGPT, because that's what it would require to answer some of the questions you would need, because all those topics, all those content's been put into the system. But that's just a rising tide. So all the boats are higher and we're all working at a higher speed. But what we haven't done is we actually haven't improved working productivity necessarily. We've improved our ability to generate content. We've improved our ability to get answers faster, relatively accurately, basically probability based. And it's doing like, it's good enough and it's working very, very well. I think we all use it every day. And it's amazing. And so I'm working more productively, faster information. But in terms of like the world's workforces, not just an information gatherer, but a workforce where people are collaborating together.
Actually, people who are using that information or using web-based applications to interact with it, they have to figure out a better way to manage those activities. Again, going back to my sort of microcosm, but in the medical supply world, you have all these computers, you have all these web-based applications, you have all this data, you got millions of, in my case, products, and what I really believe are like billions of data points around those products, because you got all these computer applications generating all kinds of activity, right, for reasons that have value, but it becomes overwhelming. There's just so much activity, so much information. It's beyond the ability of some individual person to manage that activity.
And that's just one company.
One tiny example.
One company.
One industry, one example of really a characteristic that is worldwide, right?
It's prevalent everywhere, right? So what we decided to do in looking at this problem, given given kind of my background of where I've been and opportunities that have been afforded to me, I looked at this problem and said, hey, look, this machine learning stuff's not going to do everything. It's going to do a lot of things, but not everything. And we really need to get back to some of the principles of AI that the great thinkers had way back when. And so one of the great thinkers was a guy named Carl Hewitt. Unfortunately, he died in December last year. Lived a good long life and was a huge contributor to the font of knowledge of AI. And he was he was the original thinker on like distributed computing and artificial intelligence. And he had this thing he called the actor model for computing, which basically said, hey, like theoretically, we can have this thing called an actor, and it's a computational thing. And it can create other actors, and they can talk to each other, and they can replicate, and they can do all kinds of work. And then he said, hey, I need to create a language around that. So he created this language called Planner. It's like 1972, and it never got commercial traction. Of course, the AI winter is coming, right? The amount of compute power he had was nothing there.
Well, it's a little bit like the vision exceeded the computing power of the day, too, I think was part of it.
Definitely.
Right?
Yeah, so here's this great mind with these weak computers, right? Now we have powerful computers, right? Well,
Right.
His mind, his ideas, I'm just looking at those and saying, this is a great idea. And so what we decided to do was we want machines and humans to talk together, because if there are going to be trillions of machines, which there will be, just do the
Hmm.
projections. It's pretty easy.
Yeah.
There aren't going to be trillions of people. So at the trillion number, we're like 95 machines per person. So
Yeah.
um, uh, or it's beyond that. So we're 3 orders of magnitude in trillions over billions. So in a 3 order magnitude difference, those machines better be able to talk to us. The problem with machine learning is, even though it does a really good job with these large language models of interpreting stuff that has existed in the past, it doesn't do a good job of knowing things or actually being intelligent. And
Yeah.
so,
That's
what
kind
you,
of
yeah,
the,
yeah,
yeah, that's the whole fallacy of the term artificial intelligence, anyhow, right? We can
yeah.
get into that, but they're not sentient beings and they're not intelligent. They're just massive algorithm driven enterprises,
Well,
maybe
those, yeah,
is a way to
there's
say
that
it.
kind.
Yeah.
There's just two branches. What, like, the machine learning is
Yeah.
about massive data collection and probability
Right.
distributions of topics that say, well, I asked this question, can you tell me this? Yes, it does.
Yeah.
The other type of artificial intelligence, going back to Carl Hewitt and the others, John McCarthy and so forth, who invented Lisp, um, this intelligence is called like embedded knowledge. So you're putting knowledge into code, and that code will do what you needed to do. Well, that stuff fell over when machine learning came on and statistical data was used for speech recognition, right?
Yeah.
It blew it away. So, but that doesn't mean that machine learning is better for making decisions. Now, if you take something like ChatGPT and you ask it to do a number of things and say, "Hey, I've got this process I want to do. Figure this out for me." Well, it starts to fall apart pretty quickly. It's kind of like the telephone game, because it's text in, text out. So you take one
Yeah.
large language
Exactly.
model, give it input, it gives you output. You change that to
Right.
another one, and eventually, like, your probability is getting low, and it's doing what's called hallucinations, because it has to make stuff up because it doesn't know what to do, and it just sort of churns things out. You can't really run a
Yeah.
business off that kind of, you know, that it's great for us to
Yeah.
say it's good enough, but it's not great to put that in an industrial system and expect it to do perfect work. That's when you have to get
Right.
back to what Hewitt was doing with artificial intelligence, where you're embedding knowledge into systems. So
Right.
so while we use machine learning with our Grokkit system, which I haven't even talked about yet, um, we're really focused on embedding knowledge into all these machines that has the kind of knowledge to collaborate with people and machines. So
Yeah.
that's where the next phase of AI is going, and I call it collaborative AI, where it's humans and machines talking to each other, not necessarily natural language like large language models, but in terms of basic skills. I need this done. Can you do this? No, somebody else could do it. Okay, they'll do it. That's where we need to
Right.
go. And if you look at the history again of productivity, it's how we use machines effectively. And now, like you were saying earlier, okay, what do we do? We have all these
Well,
machines, all this
yeah,
data.
I'm a guess there, but you're talking about collaboratively and the idea of a machine saying, "Hey, this is what I need to do. Can you do it? You can't do it. I'll go here." Well, when you think about it, that's sort of human behavior. That's how we operate, right? That we talk to people and we collaborate as teams. And I think that that's that idea of that side by side collaboration between the human and the machine and how that can all interact in a way to leverage that human behavior. And I think what would be helpful is if you just take a moment to talk a little bit about how you kind of laid out the Grokkit strategy, to begin to address that, right? And what are
Yep.
those, what is that intellectual property and why is it, so important? So
Yeah, I think you hit it on when you said human behavior. So what we did was look and say, okay, if we have if we need to have humans and machines talk to each other, and machines talk to each other, and we need to know what machines and machines are saying to each other, then we have to have a different way of looking at how we develop these systems. Or I actually call them actors, just like Carl Hewitt did. So, how would you build this distributed autonomous actor world? Autonomous means that a machine is working on its own, making its own decisions independently. So, that's what humans do. So, we developed a way to emulate what humans do. And if you think about work, there's only a few things that we do. Like, if we're going to work at any job, we're going to have some goals, right? And we're going to follow some plan to get those goals done. We're going to
Yeah.
execute tasks that's outputting work. We're going to respond to events like
Yep.
time or email that comes in or what have you. We're going to make decisions and process rules. Um,
Right.
that's all anyone
And
ever
and
does.
and and we're going to interact with people throughout that
Correct.
process,
Yeah, yeah,
right?
right.
So,
Mm-hmm.
yeah, I'm going to go on a computer. I'm going to do something. I'm going to get some feedback. I'm going to go to my manager, my partner, my collaborator, and go, hey, and you're going to have that constant interaction taking place. That's what
Yep.
we do all day. That's what people do all day, every day, right?
Yeah. So what we decided to do was build a system where um, you've got a human doing something, but you could also have an actor machine doing the same thing, and they could be interchangeable. One might be able to do it cheaper than the other, and one might not be available, well, so the other one can do it. So if we can do that, we can emulate what people do, and we can understand what they're talking about and what they're doing, and have total transparency. Then we've got something. Now, one of the problems with what's referred to as black box AI, the machine learning stuff, it's in a black box, meaning you can't see what's in it. So there's no interpretability of like, how did that machine come up with that answer? I asked it to do this, it gave me this answer, but how do I know how it did that? Well, that's not good enough in this realm we're going into. So when there's trillions of machines making quadrillions of decisions every day, anyone that's working in those environments need to know what those machines did. And so there has to be a protocol by which machines talking to machines and humans talking to machines is all understandable by everybody. So, I mean, a machine can interpret it, a human can interpret it. So, like for example, with iRemedy, if a machine is making these orders from suppliers, doing these orders from suppliers, you need to be able to ask it, well, what did you do, or what are you doing right now, or what's the problem? Are you stuck? What's going on? So we build a system and a protocol that allows that to happen, and so the humans and machines are all working together as if they're using one language. Now, I'm not saying we're talking in English or natural language because English is not a great language for doing transactional skill work, right? We think, we don't talk, we work.
Mhm.
And so, like Carl Hewitt was talking about embedding knowledge in this,
English, yeah, English is a pretty sloppy protocol when you really get down to it. A
it's
lot of,
great for
a lot
chat
of,
rooms like this, but it's not. It's not. It's pretty effective. Maybe who knows? But yeah,
yeah,
it is sloppy, right? And so
yeah,
when we want to get something done, like in iRemedy, look, this order just came in. I've got 3 suppliers I need to go get stuff from. Can these order bots, which we built, can they go and
yeah,
get this information, get it back to us? And if one of those order bots went down or something happened, can someone at iRemedy do that work? Well, what happens is the system will say, hey, we need a human to do this. The human will take over and work on that. So we're
yeah.
working through this and beginning to perfect it now that we have this swappability. And what it comes down to is this one simple idea.
Yeah.
And
Well, go ahead. I'll let you finish that thought. Then I'll go
yeah,
back to that digital agent.
yeah, this simple idea is if you think about every, if you look at LinkedIn or you look at job boards, look at anything where people are saying, here's what they can do, here's their job qualifications, their resumes. Um, Not a single one of those is executable right now in the world. Not a single one of them.
Yeah.
you can't just say I've got these skills and all of a sudden you're working. It takes 60 to 90 days on average to hire somebody. What we looked at was, okay, comes down to skill matching, right? So the big idea or simple idea here is you just need to know what skills people and machines have. And if you can publish those skills in such a way that any other machine or person can discover those things, or better yet, a new type of network that we've invented, we call the Paranet. So you have the email internet, you have HTTP or web internet, now you're going to have the Paranet internet. What that does is that when actors, people, machines are working, the Paranet matches the skill requests to skills that some actor has, and it does them. So, for example, at iRemedy, when an order is being placed, like a medical supply company, and that machine was down for some reason or being upgraded or something, a person takes over. All that was a skill match going from that machine to that person or from that person to that machine. So the invention
Yeah.
was here is that the Paranet is a way of having a global reach of skills of every person and every machine on the planet. And so that's,
Yeah.
we wrote a patent for that whole idea of matching skills on this new internet.
Yeah, a couple things on the just the iRemedy side because it's sort of a good case study of this example, and I want to talk a little bit about the Paranet. But what you're pointing out is a couple of things. What you've already built at iRemedy using Grokkit are some digital agents that kind of manage our order flow, right? They build catalogs, they place orders, they track orders, and so forth. It's an incredible scale. I don't need 20 people to do it. I arguably have 20 agents to do it, although it's unlimited in the number of agents that are doing the work. But so that's part of that's the real world. I mean, this isn't an idea. This is happening today. And then if there's a problem, the way it's working right now is it actually communicates with the humans via Slack. That's the way we do it. So when it identifies a problem or has a question, it'll Slack a member of my staff, and that creates that interaction now, right? And that's why I just want to kind of clarify, because this is kind of a key part of the intellectual property at Grokkit, is this idea of the Paranet, right? And I mean, is it fair to kind of compare that to a protocol, or you throw out
Yeah,
HTTP, but is there
yeah,
similarities there? I just kind of explain, because a lot of people they live with HTTP all day every day. They don't know the tech people knows what that is, but the people don't understand that I go on the internet and there's a protocol that allows me to use a website, or use a browser, I should say, to communicate with a website. That's a protocol that sort of translates my keyboard and mouse into activities, on the internet. And the reason I think it's important in the Grokkit discussion is because these digital agents, this is my non-technical explanation, but in many ways they act like people. They're not. This is not a computer to computer API programmed connection. This is more digital agents acting like humans, and therefore being able to interact with anything in the world that is used to speaking to humans. To me, this is one of the great things, because all web-based applications and all websites in the world, in my view, have one thing in common, and that is they're designed to talk to people, right? So if we can have digital agents mimic people, we pick up a certain benefit by doing that. But if you could just kind of talk through the Paranet, discussion a little bit, and what that means and what it represents.
well, you're making it easy for me because that's actually perfectly described in terms of what we're trying to do.
Yeah.
So um, there's this very subtle thing, and it's not talked about much. And when I talked about the thousands to millions to millions to billions and billions to trillions, what's happened on each transition from one thousand to million or so, that's a three order of magnitude step change. So how do we go from thousands to millions of people uh, connected? Well, it happened because this two protocols were merged, TCP and IP, on January 1st, 1983. Right, it was the same month that Mitch Kapoor launched Lotus 123. So it was a really good really good month because now
Yeah.
we could send
Hey,
email anywhere in the world.
there's a
We could
product we
send,
forgot about. I think
yeah,
they
that's
sold IBM, and God knows what
yeah,
happens with that
Lotus
product.
Notes,
That
yeah.
was the first great spreadsheet, you know.
It was the first. Well, it wasn't the first spreadsheet, but it was the first spreadsheet that was super fast. It was a killer app. There was VisiCalc and
Yeah.
Multiplan before that. And then when Mitch
Oh, there's
Kapor wrote this
VisiCalc.
thing,
That's
he
right.
wrote it in
Yeah.
assembly language. He said, "Hey, heck this! I'm not using C or Pascal. I'm doing this in assembly language. It's going to be fast." And it was lightning fast. And so for the next 4 or 5 years, it was the number one thing selling IBM PCs.
Yeah.
But at the same
You know,
time, email will
the
happen.
spreadsheet had to be one of the greatest breakthroughs of all time, by the way, though, when you think about,
Yeah,
the pre and
but
post spreadsheet world, right?
what I'm saying is
Yeah.
the same month, January
Yeah.
1983, TCP/IP for email, and then Mitch Kapor with 123. So that
Yeah.
got people buying computers and then connecting each other over
That was,
email. And so
that
the
was a good
protocol
month.
is what transitioned us from thousands to millions. Well, then in 1991, Tim Berners-Lee came out with the web, right? What the web is four things. It's a web server to put your content. It's HTML, which is a subset of SGML, the old markup language. He made a smaller version of that. He created a browser, which really is the next killer app, and it's the killer app of all killer apps because we all use them.
Mhm.
And then the magic is the protocol HTTP, so the hypertext transfer protocol. So instead of sending email and sending files back and forth, you know, you could go and just take your browser and you could put an HTTP string in there, and it would get you to any web server in the world. So that's magic. Protocols are magic. And so the problem with now that we've got billions of people and billions of computers is that HTTP was only meant as a client server operating thing where people would use a browser to interpret stuff on the web. It wasn't meant for machines talking to machines. So
Mhm.
to answer your question then is that the next magical step function is a triple order of magnitude change where it's not us, we're not the ones, it's not the humans tied to machines, it's humans tied to thousands of machines each. So each of us in the future will have thousands and thousands of machines that are working for us that are very small, doing things that are very important to us, and they're all collaborating with each other to do what we need to do, whether it's in our work or personal. This is how it'll go. But to do it, we had to come up with a new protocol. It had to be a collaboration protocol. So we call it the Paranet collaboration protocol. And what that is a way to not have to use APIs. The problem with the web right now is you can get to anything and you can program anything and do wonderful stuff. But everybody has their own API, their own website, their own data formats, and so forth. Um, Very time consuming to to try to connect to everything to know what APIs out there. So the collaboration protocol PNCP allows any machine or person to communicate in a browser. So we extended the browser, so you just use your normal browser, but now this protocol shows up. And you go, oh, what's that? Oh, I'm looking at this machine that's got this data. And here's all the conversations that machine has with those machines. Now you have this new world where you're looking at conversations between people and machines, not looking at web pages and content on web pages. So
Yeah.
your question is the right one. Like, it does a is a protocol necessary? And I'm saying absolutely, because APIs aren't going to do it. If machines are talking through APIs, all bets are off. Because
Yeah.
we won't
Well,
understand it.
in the real world, we spent a lot of time and money in the last 20 years trying to build APIs. Some work, they're very important, they have value. But
Yeah,
in the wild, wild west of the real world, people building websites and changing applications and doing this and doing that, and the accelerated, fast-paced change of the world, you can't build APIs for every purpose, and just it's not freeform enough, right? The
yeah,
perfect
but
API is the human.
yeah,
Yeah,
if you remember back in the late '80s, early '90s, there were these various content management systems and hyperlink systems and so forth, and they all had their APIs. When the web came out and people really started
yeah,
realizing what you could do for free, basically, to connect these servers and put content up, a lot of those companies just sort of went by the wayside, or they adopted to the new way of the
Hmm.
world. But this new way of the world worked, right? It got us the most productive um, multipliers in the history of the industrial revolution.
Yeah.
But now we are at this point where um, the pervasiveness of computing is going to exceed our ability to access it because
Right.
we're
Exactly.
competitively natured, right? And companies are competing against companies for better mind share and for more output to buy their products, to use their services. And since the rising tide lifted all boats, we're all more informed now, or putatively more informed. We have machines that inform us, but
Right.
who's doing the work in the future? So we set
Yeah.
out
It's
to
yeah.
build this patent portfolio to sort of protect us. And while we're building that patent portfolio, we actually implemented this code. So we now have a system that
Right.
lines up with our patents that we're ready for this future. And that's the story of Grokkit, is that we need to build a protocol that machines and humans could talk to each other.
Yeah, so I want to cover a little bit more about that. So this is, again, my right or wrong way to try and interpret that. I mentioned this to you one time in a conversation we were having. The LLMs, the chat GPTs are, the phenomenal tool now to, interact on a language basis. But the other side of the coin is to do stuff, right? And,
Yeah,
the computer to computer transactions of actually getting things accomplished. And that I think is a little bit more of the AI side of the story that Grokkit is pointed at. And that is, so you talk about Paranet. At one point, were you, discussing Paralog or something, but as being a bit of a programming language, as a way to build agents and tools that could be, that could learn processes and scale human behavior. I mean, is that a fair way
yeah,
to describe it? Because in my real world, that's the way it works. I don't have to go hire 100 people to do a function. I can take one person. They can work with your digital agents. And they can have 1,000 agents out doing their job. That's a simplified way to
yeah,
describe it, but you know,
yeah. So the way we're looking at the world is that so iRemedy, let's take it as one case, and let's take maybe like a mining company as another case. It's like two
right? Yep,
completely
yep,
different ways of running businesses. And if we take the premise that every machine can be an actor on the Paranet, and every actor works in some workforce. Well, with iRemedy, it's largely uh, human actors doing work and web stuff, right? So what we needed to do first for iRemedy was to create a way to collect information from the web and to interact with stuff on the web as if a human would do it. Now there's stuff called like web scraping and an RPA, or there's public companies out there, UiPath and so forth, that have these kind of products. Those are table stakes, when it comes to what we really want to do. So what we needed to do is make sure that we could build uh, languages that machines would generate, not humans. So we built Datify, which is a language for extracting content and converting it to data off any web page. And so we use models that describe that web page. Well, then there's other pages that are similar to that. Then we can use AI, machine learning type AI, to say, oh, that model's like this model. We can go extract information off that page. We got it. So we can go collect, create the largest catalog in the world in that process, largely automated. So that's Datify, which means datafication, so turning content into data without using APIs, right? So that's one thing we had to do so we could actually build like a catalog for iRemedy. The next thing we needed to do is make sure that any activity on web pages could be turned into functions and then actorized into a machine that could then participate with people. So Paralog is a language that is a kind of like a description language like Datify, but it's a function language that represents what you're doing. So if you're clicking on pages, we can look at that, replicate that, turn that into a system and turn it into an actor on the Paranet. So the next thing we did was we needed to create a language um, that actually does the protocol, talks to other computers without APIs, can embed knowledge to do the task decisions, all that kind of stuff we talked about earlier. We need a language for doing that. So we created Paraflow. So we have this Datify, Paralog, and Paraflow. Paraflow is the actor language, the goal-oriented, the workflow-oriented, the thing that does how humans think. Now, Paralog is how humans type and do stuff on the web. So we had to build a system that could build really good web actors, right? And so Teraflow allowed us to replicate everything that iRemedy does in terms of processing and finance and so forth. And it could coordinate or orchestrate everything going on with these other actors who were doing web stuff, Paralog based actors.
Yeah.
So we build all that
Yeah.
stuff for iRemedy. And so then at the end of the day, what we have is this very intelligent actor workforce that is doing all the things and interacting with people. One of the things we had to do besides interacting with Slack was we had to make sure that if a machine got stuck, couldn't figure something out, that it could talk to a person like immediately, like on their phone, like a link. Said, "Hey, I'm stuck." So we created this co-browsing technology, which allows anything you're doing on the web to be replicated exactly from what you're doing, not the screen sharing, but actual the document object model, the DOM, the web data that's in your browser can be replicated to any device so that a person can say, well, do this or do that. So we had to create a real-time low-level protocol that allowed humans and machines to talk when they got into a problem. So that's an
Yeah.
obstacle we got over. And so now with iRemedy, we have this orchestration of all kinds of different actors doing things, talking with humans into Slack, working stuff on the web, ordering products, collecting data, building catalogs, all this kind of stuff you talked about. Well, that's one way of doing things with these languages. The other thing is like on a mine. You imagine a mining situation. They have all kinds of safety protocols, and most of these mines today have automated
Yeah.
trucks and drills and diggers. We've built a system right now. It's a prototype, but it emulates um, protocol procedures. Like if a truck breaks down, what do you do? Well, it turns out there's a lot of things you need to do, and so we can automate that. And we built a prototype that shows this mining company how when a truck breaks down, all these people, all these machines need to interact, produce, less downtime and more following these safety protocols so that they have greater productivity. So those are two extreme kind of things going on there. One is web based, the other
Yeah.
is talking to automated trucks.
Yeah, that's what I was going to point out for everybody. So we're talking about the mining deal. I know is something you're consulting on right now, but we're talking about I don't know what kind of mine, but some sort of whatever a raw material mining
Yeah, iron ore
operation that
mine. Yeah.
uses diggers and yeah.
Mm-hmm.
So, it uses heavy equipment and it's about as it's funny because when you think about it even sort of symbolically, right? It's as far different than a web-based computer application as you might be. It's physical, it's in the dirt, it's out there, dealing with natural resources. But it does bring, and illustrate that even that truck is got CPUs in it, you know, probably a ton of them, and then all the
Yeah.
equipment that services that truck, and all the computers managing the people that need to interact with that. There's once again all this sort of computer based activity taking place that again needs to be coordinated, need to be run at scale, needs to be automated, need to interact with. When you think about it, that truck, that equipment servicing that truck, those people, all those CPUs that were built were pretty much designed for human interaction. That's where when Grokkit can come along using the Paranet and Paraflow and Paralog, it can mimic that human. It can interact with those CPUs as though it were a person, was a person, whatever
Yeah.
that is. But it can mimic human
Mm-hmm.
interaction, right? By the way, that's you could. It's worth commenting a little bit because this is an interesting thing about people get into this paranoia which may be legitimate, right? And that is, the worry about uncontrolled AI. That's that difference between black box AI, an AI machine that takes off and gets out of control, or it gives a tremendous amount of power to the wrong people in the world, versus the idea of para, right? And that's alongside of. And if you might want to explain, Jim, a little bit about where that word comes from and why you choose to use it, in the work that you do at Grokkit.
Well, yeah, there's uh, one of the problems with the information age, and we've kind of moved from the information age into this sort of fourth industrial revolution or 4IR, where we have robots and IoT and all kinds of automation going on. The world's trying to make sense of all this stuff, and so we thought like the last thing we want to do is lose human dignity in work, right? There's all kinds of books on the future of work and these dystopian worlds that we could get into, and government's just going to pay us checks and we can't work because the machines are doing all the work. Well, I don't describe to that. I'm not a dystopian. So what we want, we have to, you know, carefully design the future. We can't just let it happen. And so what we set out to do was say, okay, there can't be a world where humans don't know what computers are doing. That just can't. That's a non-starter. And
Yeah.
Facebook had built a system a while back where they had these sort of agents that were inventing things and ordering stuff, and they got scared by it because they realized these machines were talking to each other. They had no idea what those machines were doing, so they shut that project down. And so
Right.
we don't. So if I could declare a manifesto for Grokkit, the Grokkit manifesto is that no person or no machine should ever have another person or machine do something that they don't intend them to do. Right? So machines shouldn't do something that they shouldn't do. And so one of the problems with like large language models right now, and the reason Musk and others are kind of worried about this, very worried about it, is that it's kind of gone out of control. So I think there are certain types of people in the world that are in positions of technological advancement that believe in ideas like transhumanism and that we're all going to
Yeah.
evolve toward this, transhuman state and just let it happen. Well, I'm not a transhumanist by any stretch of the imagination.
Yeah.
Um, there's so what I want to do. The Grokkit Manifesto is that we need to understand everything that they're doing. So one of the patents we built into the company, and we have about 25 patents filed now and several issued, was that we want to have the Paranet set up such that if Tony, you want to know what these actors are doing, and you want actors to tell you what these other actors are doing, and you want to maybe
Right.
buy or license another actor that's really smart at telling you about what actors are telling what actors are doing, you can do that. What that allows us to do then is have this observational intelligence, if you will, of your workforce. And observation intelligence means you just have actors that you've built or hired that look at the things you're doing and tell you what's going on and say, hey, Tony, should they be doing this? And if the manifesto is such that no machine can do something that it does without being an interpretable conversation, then it shouldn't do it. So we just believe that we should shut down any type of machine activity that's doing things that we don't want them to do. And so black box AI, like large language models, we don't know what they're doing, how they're making things up, but we do know what they're saying when they
Yeah.
generate it. We can look at that and interpret that. We can have large language models actors that are interpreting large language model output. So that's the para intelligence is what we're talking about to sort of counteract the paranoia, if you will, if I can munge those two terms.
Yeah. Yeah. That's the idea of the word para alongside of, or,
Yeah.
scaling the human behavior, right? Rather
Yep.
than, you know, the rock and roll world of the computer takes over and does whatever it's
Yeah.
going to do.
We don't want that to
Yeah.
happen.
No, we don't want that to happen. It's interesting. I think Musk is talking about truth, chat or truth AI or something. But I think the other word is ethical, right?
Mhm.
It's at the end of the day, I'm still a believer in humans. I'll stick with the human. All right. But I think that, Grokkit having that, sort of ethical behavior. And that, by the way, is one of the key reasons for the patents. I mean, the patents create equity value, which is extremely important. This is a business enterprise, and you're there to create value to your shareholders eventually and to customers and so forth. But they also provide some of that ethical protection, right? Because you limit access to potentially bad actors who might want to access, some of those ideas. What is, how many patents do you have pending, or what was the patent portfolio look like at Grokkit?
Well, yeah, we did two omnibus patents. So an omnibus is a large set of patents that go together, kind of semantically correlated.
Yeah.
So the first patent was to, you could you can consider it to be uh, information extraction patents, the languages and
Mhm.
so forth necessary to extract ideas, content, and that's a series of languages and so forth, and automation of languages. So we create a language, like we said, Datify is a language, description language. We patented how that language works, and then we patented how you would generate that. Because in the future, we talk about trillions. In the future, we can't have people writing code. We have to have machines writing code. So we built these languages
Yeah.
such that machines would write that code for us. So that
Hmm.
we did a lot of protection around how we would extract information and manipulate it. And so that set of patents then lines up with the next omnibus patent set. And that's the first one was 12 patents. The second one's 13 patents, I believe. These latest 13 patents were all about the Paranet. So how humans and machines talk to each other, how machines observe other machines, how we actually um, create actors and give them skills in the Paranet. So it's all about skills and actors in this future world of machines talking to people. So that's that set of patents, and like we did that because, like you say, we do want to prevent uh, like rogue uh, technology from sort of taking over. And so, if in my limited view of the world, like working with you,
Yeah.
we want to build this workforce that's super effective. And so, as you as CEO of that company, you want to make sure that your workforce, you know everything going on in that workforce, you know all the
Right.
decisions were made, why they were made. Well, this actor-based, Grokkit Paranet workforce system gives you all that. Well, if everybody has that capability, and you're the only one right now, but if everybody had the capability, then I think it's a better working world that we're in, where the transparency is there and the interpretability, and then we're not afraid of the AI because we know what it's doing. If it's doing stuff we don't want
Yeah.
it to do, we stop it from doing it.
Yeah. You're controlling the intent and the
Yeah,
goal of the end result. That's really, like, to your point. If that's the case, if that's the base design, well, then you don't lose control. You don't have that. There's nothing to fear. I mean, you want
yeah,
appropriate controls and borders and, control over the process, but you're not into the black box. This is the black box that we fear, right? That's,
yeah.
not knowing what the machine is doing, and the machine just takes off and, has a confused idea of what it was supposed to do, and that confusion leads to a bad outcome potentially,
In the black
right?
box, we have, like just normal image detection and, in our cars driving and avoiding objects. That those black boxes
Yeah.
are good because they're meant to do one thing. The
Right.
black boxes that actually make decisions for us in business are the ones we need to be concerned about because we don't know how they're thinking, right? So we want to know what they're thinking. Of course, they're not thinking, but they are processing knowledge that have been they're capable of doing. And so when they process knowledge and make decisions and start performing tasks and work, we should know what's going on there. So we built a system to do that. I mean, soup to nuts, this is a system that says, for the first time, let's have a persistent protocol because HTTP isn't. Let's have that protocol
Yeah.
work inside your workforce so that all things are persistent, all decisions are persistent, and they're transparent. And if that thing's producing at a higher rate than without it, then you'll continue using it, and your confidence in it is going to grow because you'll know what it's doing. And then there's a funny thing happens at scale. Like right now, we're all feeling the wonderful effects of large language models and ChatGPT. The scale of all those documents that they extracted and put into topic vectors, the scale that we're getting
Yeah.
for free effectively is amazing. The scale we're going to get with the Grokkit approach on the Paranet is that it's all these skills around the world that are available to us. So Tony, in some future point, not too long from now, hopefully, as you grow your business, what's happening is you're not building anything. These skills are available in the Paranet, and you're just hiring them to do the work. And
Right.
so they come in and, like I was saying earlier, it takes like 60 to 90 days to hire a competent person in some role.
Yeah.
You're,
Yeah.
the time to take to hire somebody on the Paranet or hire some actor is 60 to 90 milliseconds, effectively the latency of the
Mhm.
internet. And
Yeah.
that's a
It's like
huge, that's a huge change in the way we
yeah.
hire.
It's like a human skill in the reflected in the form of a digital agent, but controlled by a human ultimately
Yeah.
at scale, right?
Yeah.
So you could go
Yep.
out and say, hey, here's these millions of digital agents sort of in the Paranet, and I want this guy, this agent to do these things, and it's there, and I can hire it in
Yep.
using, layman's language of today,
And if you
right?
open, you open up your, so your browser while you're doing work, and you say, I'm using the Para browser as an extension to the browser, and it allows you to use this
Yeah.
PNCP protocol. It doesn't affect your regular work, but if you're using the Para browser, it's connected to the Paranet. So one improvement to what you just said is that while you're doing work and your actors and your people are doing work, it'll sense skills that
Hmm.
are out there. It says, well, I see what you're doing. I can either generate one for you that does it faster, or there's actually actors that have those skills that can do it right now. And then at a point of trust, you say, I'm just going to use the Paranet. As I'm working, actors are showing up and they're doing work for you, and you see what they're doing. It's instantaneous. So I'm painting this future of the world of the next internet where um, large language models, yeah, we get that. Here's what they do. But I'm saying now, in the skilled world of the Paranet, while you're working,
Yeah.
Tony, and while everybody else is working at iRemedy, the Paranet's
Yeah.
actually looking for faster, better solutions with higher quality. And you'll know that when they get hired, and they might be automatically hired because you might just have a budget that says bring them in when you need to. And they prove to you that they can do the work for cheaper. So it's cheaper to hire them to continue what you're doing. That's the future we're
Yeah.
heading toward. And that's why we need this protocol
Yeah.
that's transparent.
Yeah. So, we talked a lot about scale, and I'm going to wrap this up here pretty quick. So we've run a little bit long, but, we talked about scale, and I just, want to reflect on that for a moment. In your experience, you had Microsoft, and I don't know if we clearly, stated all that, but you're an early developer of DOS, which ended up licensing over to Bill Gates, became Microsoft. And, you did the database work there. So you experienced that, right? Saw the Microsoft phenomenon happen. And then, of course, you were there for Amazon, really when Amazon converted from a bookstore to a seller of everything. You're right on the front lines of building that. So you saw that activity, you know, and then, we both lived through this, last 20 years in the tech world. How would you compare using the scale term? What is the potential impact? When you think of the work that you've done with Grokkit versus the work at Amazon versus the work at, in DOS and Microsoft. I mean, just how big is this potentially in terms of its impact? Because that's the whole thing that has changed in the world today is scale and impact, right?
Yeah, so it's a it's a matter of historical perspective, right? So when Tim and Pat and I were working on DOS, and I would go drive up to Microsoft and give them the latest version, and I'd get you know updates from them on languages to install and so forth. We were kind of in it, right in the middle of the thick of it. And even though we knew we wanted to beat the mainframes, it was better than what we'd been working at the University of Washington. We didn't
Yeah.
see it, Tony. I mean, right? Because there were still only thousands back then, right? We didn't see it. So then looking
Right.
back, I should have seen it. I kind of did, but I didn't act on that. So
Hmm.
then when I was at Amazon, the they had this Amazon was kind of falling apart, if you will. The stock had come down and they'd laid off people, and it was a bad time. And they tried these different approaches to this marketplace. And so I'd come in and sold a couple of companies to them, and they said, "Hey Jim, can you deal with this this problem of these third parties?" So we built a marketplace and launched that. And at the time, I'm sort of in the thick of it. I'm dealing with all the complaints with like the Gap and Nordstrom and so forth. Like, why aren't our sales as
Yeah.
much as you promised they're going to be? You get in the thick of that, and you don't really see. Well, today it's a $350 billion business for Amazon. It's the largest
Yeah.
catalog, I
Yeah. Well,
think.
it's hard to anticipate.
Yeah,
Yeah. Yeah.
when I was in the middle, I mean, I've got the first shirt from Old Navy in my closet here, the first, item number zero from the marketplace.
That's cool.
But
Yeah.
you can't see it. So now, like your question, for the last 20 years, I see it. And so I set out to say, okay, given, hindsight, I need a little foresight now. And so the foresight is,
Yeah.
okay,
Mhm.
chips are going to be proliferating. Population's not growing fast enough. That's good. It's fine. But and AI is taking off, but it's a black box machine learning AI. What would be necessary to work harmoniously in the future in this fourth industrial revolution? What's necessary to do that? So we as a team looked at all those things, and we now see it. Now it's not like day one, here's how it's going to work. It took several years. And now we're at the point where I can just say, hey, it's all about workforce automation in the future. And here's how it's going to work. Stage one of Grokkit is just to go sell a bunch of workforces, kind of like Slack or Teams. But Slack is about people, maybe little robots, little bots that they use. But it's all about, instant messaging with people. Not workspaces, but workforces. So Grok is about building workforces like you have at iRemedy. A workforce is machines and computers working together, getting stuff done, right? And you're seeing all this communication. That's nothing like Slack and nothing like Teams. This is a whole new way of looking at the world. So we're going to sell a bunch of those, hopefully. And in the future, once we get enough scale, then it becomes this just future of work. The Paranet of actors. It's the largest, recruiting company of digital actors or agents, if you will, digital workers. So that's where we're trying to go. But in order to get there, it took us years and years of thinking, where's all this stuff going? What kind of language is needed? We need a protocol. Now we have it working. And it's working very, very well. And the future is, I believe, the next internet, and I'm calling it the Paranet. There's nothing else
Mhm.
really like it. And it's funny. I used I used ChatGPT, and I said, hey, this is fantastic. Hey, tell me all the categories of programming languages that exist. And I should know these. And it generated for me 25 different categories, two languages each example, perfect examples. Yeah, I get all that. Great. Where's the thing I'm doing?
Yeah.
It's not in there. And
Right.
I've been, my business plan right now has a couple pages describing what we are. And I don't reference technology at all. I reference future workforces, how they work together. Um,
Mhm.
and when I finished writing that, I realized this is it. There are no programming languages to do this. There's nothing. There's no analog to it. But it is what Hewitt talked about in 1972. And I wish I could sit down and have a chat with him. One of his proteges, a guy named Gul Aga, did his PhD work on the future of distributed actor computation. I want to talk to him. He's a
Yeah.
professor somewhere.
Yeah.
So that vision he had, I'm just kind of grabbing it and saying, I think we can do it. I've got foresight this time for the first time, and I'm looking forward to leaning into that
Well,
future.
Yeah, it's a little bit like there was the industrial age or the industrial revolution, then there was the information age, or, but now what you're describing is really sort of a workforce revolution, right? Because you're
Yeah,
talking about massively multiplying the scale of what people can accomplish by, using, the platform, which seems to be very well protected by the intellectual property. So, Jim, yeah, I just always love these conversations. We've had hundreds of them. They're so good and so interesting, and there's so much more we can talk about. And I think that we will, plan some additional time where we can get together and talk in more specifics about the various Grokkit applications that I know that you're developing. Not only with iRemedy but with some other, client opportunities that are out there. So would like to thank everybody for taking their time to share with us today. This podcast is, at YouTube and other locations. We would encourage you to subscribe to the channel and like it and share it with other people and comment, down below here on the YouTube platform so we can hear from you and hear questions and be happy to interact with you at any time. So thank you, everybody, and have a great time. And Jim, thank you very much. I appreciate your taking what turned out to be an hour and a half with us today. It's super interesting information.
and right now, Tony, we don't have a website up. We've been in stealth mode, but since we have all these patents, we can talk about it. So a
Yep.
website's forthcoming. It'll describe a lot of things we're talking about here today.
Yeah, we need to focus on that. You've been too busy inventing. Now you need to get some web
Yeah,
activity going. So
definitely.
cool. Thanks, Jim. Talk to you
All right,
soon.
thanks.